Hello, today we are going to talk about how to disassemble, decompile Java bytecode back to Java source code. So for that we are searching on Google for a Java disassembler or Java decompiler, and the option that I always used in such a situation was JD Java Decompiler, this project. So it has two options. There's JD-GUI, which is this application, graphical user interface application. And then there's a command line up, if I remember correctly, but we're going to use JD-GUI. Okay, so let's download JD-GUI. I'm going to download a jar, this thing, to this directory, save. Okay, so it's really small, just 3 megabytes. It's has a jar extension, so this will require a Java runtime. And then you're going to run it as Java space -jar and then this file. Okay, let's get a Java runtime. I'm on Kubuntu 22.10. The options of installing Java are like this. You go become a super user. You go Java -v for version. It says that it's an unrecognized option. Okay, now it says I have Java already installed. I installed TextLive, and maybe that's how I got it. Okay, other options of getting Java is so installing it from Ubuntu packages. So that's apt search JDK, and then grep JDK. So there's the default JDK, which is probably the package that you should use. Then there's OpenJDK version 11, 17, 18, 19, 20, and 8. There's also the option of going straight to the OpenJDK website and downloading what's available from there. So it says download and install the latest open source JDK, which is JDK 19. It has binaries available from the OpenJDK website. So for instance, I could go with Linux x64. Let's see what this contains. Okay. Or I could go with Oracle's JDK 19, which I might use as the compressed archive, or the Debian package. Okay, so all the files have finished downloading. I could either execute this deb, which is the Oracle JDK version 19 in Debian deb file format, or I could install the same thing, so Oracle Java SE Development Kit 1901 from this file, or I could use the OpenJDK from the OpenJDK website, so not Oracle's version, but the openjdk.org version from here. So let's see how such a RGZ file looks like. Extract Z. Okay. So this is how a usual Java JDK looks like. There's a bin directory, there's a Java which is the runner, Java C which is the compiler. Okay, so let's see if we can use this thing to run JD, the decompiler. So Ctrl-Shift-V minus jar and then JD. Okay, so one of the many Java executables that I have in here or in /usr from Kubuntu 22.10 packages, then minus jar, command line parameter, and then the JD-GUI jar. Okay, let's see if it can open itself. Eventually, let's make a copy. Like this, Ctrl-Alt-C, file, open file, Ctrl-V. So this is the, looks like the swing file open dialog. This looks like a swing graphical user interface. Okay. And usually when I decompile in C# DLLs or access in Java jars, if possible, I try to extract all of the jar file, in this case, to a directory with source code projects and source code files, etc. Let's see if JD-GUI has this option. So file save all sources. Let's create in here a directory. So you could either use the GUI of the decompiler and keep expanding in there and not really finding what you're searching for. Maybe the search doesn't work as well as you want it. But the other option is to just convert the binary file into a source code project, and then we have access to all of the source code. Okay. So we started Java and we did not background it, so Ctrl-Z-BG. And now let's extract this directory. So it's a zip file, unzip. I'm in the wrong directory. Okay. Okay, so this is the source code. I don't have a Java ID yet. Let's see what Visual Studio Code knows what to do. So I have decompiled the Java source code for all of the classes, all of the Java bytecode that's part of this process. Okay, so each class ends by telling me where the .class file is located, so where the bytecode file is, and this is the source code file with the extension .java. I'm not sure why it puts this many useless comments. Okay, so let's look at a method that actually has code in it. Maybe it has debug symbols and it tries to match the decompiled line to be at line 52 because the line 52 in the source code, in the original source code, we know that in the original source code this line is at line 52 because maybe it has debug symbols. That's what I'm guessing why it makes this many empty comment lines. Okay, so in a decompiler, what we want as little obfuscation as possible. So we want the publicly available identifiers to have the same name, which is the case, like in class names and in public methods names. But then, if possible, we also want human readable identifier names in the private symbols, in local variables, in other identifiers that are not part of the API of the binary jar file. So string builder is named buff, not --a or AA. This seems similar to what a human would write, this source code. This seems too good to be true, to be written by a human. Index O. So we're looking at the identifiers and the body of a method that was decompiled to look as human, as close to what a human would end up writing the body of the method. Okay, so these are probably the Java docstrings, the Java docs, which probably are not available in the original JD-GUI jar file. It's interesting that we can guess that this method doesn't have a Java docstring, while this method does have a Java docstring on line 60. And this method has a ton of, this class has a ton of Java docs. Okay, so we have enums, we have classes, abstract, public methods, final. I didn't see any private method yet. I'm not sure it can do such a thing. There's one. Private double get node height. Get node size. Okay, so this is more than enough for me. The way JD-GUI works and the quality of the generated Java source code that was generated by decompiling the jar file to a directory with source code files is enough for me. Okay, so where is the swing? Java auth, Java auth, Java X swing. Yes, where's the file chooser? In here. So this is probably the left-hand side preview. The next step to do would be to install an IDE, build this source code, make sure that the generated bytecode is similar to the original bytecode, such that we can run the JD-GUI application, and then run with a debugger to be able to read and understand better the source code. When I run with the debugger, I better understand what each class does and what each method does, and I tend to remember better where the source code actually is, in which file and in which method. Okay. Module info. Meta info. Okay. Let's install an IDE and see how far we can go. Okay, let's download IntelliJ IDEA from JetBrains. Community edition should be more than enough. Okay, download the targz. Save. Okay, so we finished downloading. It's IDEA IC and the extension targz. So tar minus xzvf and then IDEA. Okay, let's see what this thing is. Install Linux tar. Unpack the IntelliJ IDEA distribution archive that you downloaded where you wish to install the program. We will refer to this location as your installation home. To start the application, just run idea.sh. Initialize various configuration files, config JetBrains. Okay, let's make sure we don't have such a direct configuration directory already. So .config JetBrains. No JetBrains for me. and let's put it into .opt. F6, and let's rename this thing just idea IC, and then it says in the bin directory I should run idea.sh. Let's see if it shows some errors. So this will use the JDK that's available on my system, so installed from Ubuntu deb packages. Okay, so open an existing project from disk or version. Okay, so let's start IntelliJ IDEA again. File, close project, open an existing project, the directory where we decompiled, okay, and then we're going to try to build this thing. Okay, it says that the SDK is not configured. Let's configure it. So it's in the parent directory. Okay, so it says Oracle OpenJDK 19. The name of the project, no, JD2. Okay. Rebuild module A. Okay, 32 errors. Let's wrap the lines. There's the preferences. Just a second. Okay, so I've enabled line wrapping such that there's no left-right scroll bar, just a up-down scroll bar. And it says that the decompiler has created some Java errors. And I don't know how to read this source code. What happens in here? So this is a new. I don't know what happens here. So this is probably a constructor. This is probably something generic. These are the parameters of the constructor, which the constructor, where does it end? Nowhere. And then the constructor has parameters 1, 2, 1, 2, 3, 4. So 4. 1, 2, 3. So this is the third, B consumer. And where's the fourth? One, two, three, and then 3 consumer, B consumer, and 3 consumer. So there's probably a and then this ends here. Okay, let's rebuild. I have no clue why it says that the source code does not compile. I have no clue why it creates source code that does not compile. Such it did not put a comma. There's no settings, are there, for the version of Java that's needed. So the source code, Java source code files should respect the Java version which is this configurable in JD-GUI. Write original line numbers. So you can't say generate Java code that compiles on JDK 19 or on JDK 8 or on JDK 7. So I don't know exactly what version of JDK it targets when it decompiles. But still, since JD-GUI was released in 2019 and I have the very latest JDK 19, I would guess that the source code, Java source code generated by JD-GUI is for a previous version of Java than JDK 19. Okay, so unfortunately the source code generated is not immediately compilable, but then maybe you want to just decompile a small number of classes, and then you can fix all of the Java compiler errors yourself by hand. In here, what does it? Doesn't find the JList. Poke later. Runnable do run. So you create an empty runnable or something. So you can fix all of the Java compilation errors by yourself, by hand, one by one. And maybe they're enough for your usage. Maybe you just want to decompile some jar file that was created by you, and then you lost the source code to it or something. Even with these compilation errors, what the JD-GUI does is enough for me and for my needs. Okay. Let's explore a more complex example. So we have the most complex example that I can think of, which is an Eclipse built application, an application that uses the Eclipse framework, which is the RSS feed reader RSS owl. So let's download it for Linux. Okay, finished downloading, 24 megabytes. Let's see what's inside. So this is Mozilla Firefox Zul Runner for a web browser plugin, web browser control, because the body of the RSS article is shown as HTML in a web browser GUI control. Then there's the OSGI usual Eclipse plugins. Let's see if drag and drop works. What's the most basic of them all? It's 16 kilobyte. Okay, can we open two jars at the same time? Yes, we can, in different tabs. So there's native.so files for Linux, including Mozilla, that will then use the Zul runner. And then the Java source code that uses these SO shared libraries on Linux and exposes them as Java classes. SWT shell, decorations, canvas, there's code navigation by clicking. There's back navigation, which uses the standard Alt-Left keyboard shortcut. Okay. Can navigate packages, files. Types. Methods. OS class. Okay, so we can use JD-GUI to explore the source code of a jar, or we can convert that jar into a source code directory with Java source code files. Okay, so thank you to the JD Java Decompiler developers. Thank you very much. Bye.